In this video, I want to get us acquainted with a relatively simple musculoskeletal model we'll be using to analyze the full range of factors that contribute to torque production at a joint. So I have a relatively simple upper body model here. We've got a upper arm and a shoulder joint and an elbow joint and a couple different muscles. And what I'm going to do to illustrate this excitation activation stuff we just talked about is I'm going to simulate sending a neural excitation signal to just one muscle, the long head of the biceps brachii. So as you probably know, it's the major biceps muscle. So I'm going to do exactly what I described in that last video. I'm going to send a signal from the simulated brain here to turn the muscle on for about, half a second, a third of a second, and then turn it off. And we'll look at both what the activation level of the muscle is and what actually happens in the simulation. So let me add what the simulated activation curve is, and then I will play the simulation in slow motion. So we'll watch this a few times, and hopefully you can see the dashed blue line on the plot. That shows what timestamp we're at. So this will loop back to the beginning, and notice how there's a delay between the muscle turning on and when the muscle actually starts producing enough force to pull the forearm up and flex the elbow. You can see what the muscle's activation level is in blue, whereas the excitation level is in red. And the two things to notice from that last video, number one, there's the delay between the onset of excitation and the onset of maximum force production. And there's also a longer delay between when the excitation signal turns off and when the muscle stops actually producing force. So this is one important factor that's going to play a role in determining, especially for high impact or high intensity activities, what the force production of your muscles looks like. There's a few more subtle points that we'll go into detail on. You might notice that it seems like the forearm is actually not moving as fast as possible, even right now, when muscle activation is very high. And that has to do with the muscle force, force-length relationship, the muscle force-velocity relationship, and something called moment arms, which we'll talk about later this week. So I'll let this play just a few more times so you can get a feel for what this looks like. And again, this simulation that's running on the right is entirely consistent with the force length, force velocity characteristics of muscles, the Newtonian laws of physics, and this excitation activation relationship. So hopefully seeing this video makes this a little bit more clear for you.